All right, welcome to 3.2 or lesson 3.2, day 2, part 2. There's a lot of 2's in there. So let's talk about, again, making a difference or distinction between discrete and continuous. The definition for a continuous function is a set of data is said to be continuous if the values belonging to the set can take on any value within a finite or infinite interval. I want you to understand, first of all, that whether our function looks like this and has 2 endpoints, or whether it looks like this, for example, where it's a line and there's no endpoints, that it can be continuous. So a continuous function can be either finite or infinite. However, the key to this is, do I have values between every other value in this function? And I guess what I mean is, let's take a look at an example of a continuous function. And we're going to use Desmos for this. And the key is, I want you to look at the values here. When I first look at this, I see this divided by 1. Every square here is 1. And I see that. As I zoom in, though, I continue to zoom in. I now go down to, after a few zoom in here's, everything is now by tenths. And yet I still don't see any break or dots between, the line is still going through every point. And as I continue to go in here, I can get down to infinitesimally small or very small increments, and yet I still do not see a break in the line. And my numbers are getting down to now where I have something like 0.000000009, or 5 is a value, I should say. And they get smaller and smaller, and I have these small number of increments here, and yet I do not see any break in the line, which means this is continuous. Again, I have any value I can travel through from one point to the next. So remember, we talked about traveling from 1 to 2 when we started. I could travel from 1 to 2 here, and I zoom in really quickly, and I don't see a break between 1 and 2, or 3 and 4, or 2 and 3 for that matter. And I get smaller and smaller and smaller. That is an example of what something is continuous. For something that is discrete, we have a set of data is said to be discrete if the values belonging to the set are distinct and separate. They are unconnected. Here's the big key, unconnected values. I'm going to sketch a graph here real quick. I have a point here, and a point here. If I look at it, maybe this is 1, maybe this is 10, maybe this is 15. This means there are no values between 1 and 10. There are no values between there. There is no point. Okay? I could also say maybe this is 4, 12, and 18. I could also say there's no values between 4 and 12. If I want to look at this a little bit better, I know I have the ordered pairs 1, 4, and 10, 12, and 15, 18. But for this function, two, 8 would never exist. Because there is no value of 2, and there is no value of 8, there is no value here. And that is why this is discrete. I can't connect the dots because there is no value at this 2, 8 point. There is no value there. There's only values at 1, 4. There's only values at 10, 12. And there's only values at 15, 18. My only inputs are only 1, 10, and 15. Those are my only inputs. I have no other inputs. There are no inputs at 2, nor 3, nor 7, and etc., etc. No values between 1 and 10 that exist. None between 10 and 15. That is the difference between continuous and discrete. These are some great examples of continuous and discrete graphs. The height of a horse. I can have any value within the range that a horse's height. I could have, if the height of the horse is 10 foot, I could have, any horses can grow maybe from 0 to 10 feet in the air. That seems kind of tall. Probably not that tall. But I can have a horse at 1 inch, and 5 inches, and 60 inches, and 70 inches. Those are all leading up to 10 feet, which would be 120 inches. Any value would work between those 0 and 120 inches, or those 0 and 10 feet. Time to complete a task. I can be measured in seconds, or hours, minutes, seconds, fractions of seconds. Outdoor temperature at noon. There's any value within the possible temperature ranges. So realistically, maybe the coldest temperature on Earth being negative 100 or so degrees Fahrenheit or Celsius, or negative 150. The hottest recorded temperature, I think, is 132 degrees Fahrenheit, or maybe a little bit warmer than that. Any temperature is possible between that range. The speed of a car on Route 3, assuming legal speed limits. I don't know where Route 3 is, but again, I can go anywhere from 0 up to 85 miles an hour if that's the speed limit, any number of speeds in between there. In discrete, though, you'll notice the examples. Number of people in your class. You don't have fractional parts of a person. That's would be kind of weird. The number of TV sets in a house. Again, you can't have parts 7/10 of a television or 0.6 televisions. I mean, what is that? That's maybe a screen and I almost said dials. I'm thinking of televisions back when I was a little kid or something like that. But you can't have parts of a television. The number of puppies in a litter. You can't have a fractional puppy. What a terrible thought. The number of questions on a math test. There are no incomplete questions. I can't get half of a problem done. I'm either going to get it all done or none of it done. Those are all great examples of discrete. So now as we get closer towards the end of 3.2, let's put together everything we've talked about so far in this section. We're going to use mapping to determine if a relation is a function. So we have a given relation that represents the number of students and the number of classrooms the school has for the corresponding number of students. If a school has 40 students, it has 2 classrooms. If 45, it has 3 classrooms, and at 50 students, it has 4 classrooms. Here we're going to list our students, and we're going to list our classrooms. We're going to list our students as our domain, as our x values. We're not going to repeat any of our values, though. If we see a repeating value in the data table, we won't put it over in our mapping. So we're going to have 40, 45, and 50. Our classrooms, we have 2, 3, and 4. 40 students relates to 2 classrooms, 45 students to 3 classrooms, and 50 to 4 classrooms. Okay. Is this relation a function? The answer is yes, because there's no repeating x. Is it discrete or continuous? Well, we'll get there in a moment. Let's do our domain. So for our domain, 40 is our minimum. Well, actually, we have to answer if it's discrete or continuous first, because that's going to affect how we write things. Discrete or continuous. Can I have half a classroom? Can I have half a person? And the answer is no, so it must be discrete, which means I'm going to write my domain and range a little bit differently. My domain, then, I'm going to write with brackets. I'm going to start with my minimum value, which is 40. I'm going to write my next biggest number, which is 45. And I'm going to complete my domain with my maximum value of 50. For my range, I'm going to start with my minimum y value, which is 2. I'm going to write my next largest value, which is 3. And finally, my biggest value, my maximum value, which is 4. And that would be my domain and range for this situation. Again, students in classrooms, I can't subdivide them. That's why we have a situation where it's discrete. Discrete leads to writing my domain and range as just a set of numbers. And again, this relation is a function because my x does not repeat. In this example here, we have age of boys and their heights. So I'm going to put age over here and height over here. When I fill my mapping, one key is that you'll notice is I don't repeat values. So I'm going to go ahead and do our mapping really quick here. All right, I'm back. We've put all the numbers in here. Notice I did not repeat the 10 when I drew my columns. So going back here, an age of 7 relates to a height of 41, according to this data. A height of 8 goes to 45. An age of 9 goes to a height of 49. An age of 10 goes to a height of 52. But an age of 10 also gives us a height of 53. Age of 11 goes to a height of 55. And an age of 12 goes to a height of 59. I apologize if I confused that. 7 to 41, 8 to 45, 9 to 49, 10 to both 52 and 53, 11 to 55, and 12 to 59. What I notice here is 10 has multiple outputs. 10 also is repeated. So is this relation a function? No. 10 is repeated as x. We're dealing with height and age, and I can divide height and ages up, so this function would be continuous, which means now I need to identify my minimum or maximum values. 7 is my minimum age, 12 is my maximum age, so my domain is going to be written as an inequality. 7 is less than or equal to x, which is less than or equal to 12. I can also write it as a interval notation, which is 7, 12 with closed brackets. My range, my minimum value is 41, my max is 49, so I can write this as an inequality of 41 is less than or equal to y, which is less than or equal to 59, and again, interval notation of 41 to 59. And that's how I would do this one. Again, it's not a function because I repeat my 10s. I don't write down 10 twice in my mapping, but the two arrows here shows me that I have both multiple outputs, meaning it's not a function. And age and height, I can break into smaller and smaller units, therefore it's continuous. One final point here is a vertical line test is another way to determine if something is a function. It states that a relationship is a function if and only if a vertical line does not pass through more than one point on the graph of the relation. The key is it does not pass through more than one point on the graph of the relation. And we'll take a look at what this looks like. I have a number of functions here, and it states that the relation is a function if the vertical line only passes through the graph one time. So we're going to do the vertical line test for this function. And as I move this vertical line throughout this function, I don't cross through it more than once. Therefore, this is a function. Again, looking at this relation, at no point do I cross through this graph more than once, even though it kind of looks like it at the end. So this is a function. Looking right here, I cross it through twice in any number of places. Therefore, not a function. I've gone through and mapped the rest of them, and you see that the two areas where there's not a function, I cross the graph twice, even with these 2 points here, which means I have the same x value and a different y value.